Okay, so we are supposed to do this experiment on Tuesday. So you are still going to get to make this model. It'll just be whenever we return. So I thought what I would do today is make the model for you, and you can see how it goes. And you are going to be putting this into your journal, and this will kind of help you when you go to make your model. So what we're doing is we're making a model of the Earth's layers. So we read about this last week, and so we're going to start off, and we're going to have a little small ball of red Play-Doh. That's going to be our inner core, and the reason we're going to do it red is because the inner core is the hottest layer. It's like the temperature of the surface of the sun. It's made out of iron and nickel, and that's going to be our solid inner core. Okay, so you'll be making one of these with a partner, and you'll see why here in a few minutes. So after that, we're going to take our orange Play-Doh, and our orange Play-Doh is going to be the outer core. So that is the liquid iron and nickel core, part of the core that is around the inner core. Okay, the inner core is solid, the outer core is liquid, and that inner core, they're made out of the same stuff, but the inner core is solid because it has so much pressure on it. So if you wonder why one is solid and one is liquid and they're made out of the same stuff, that's why. So see what I did? I just kind of flattened it out a little bit and wrapped it around, and then did it kind of like a dumpling or something, and I just kind of smooth that out, and I want to get it as smooth around there. But notice I'm not really mashing, because if I mash it, I'm going to make it flat in the middle, and then my inner core won't be round anymore, and I want my inner core to be round. So I'm going to kind of fix it like that, and then I'm going to roll it around again and make it a sphere. Remember, everything from those words that we did the other day, everything was a sphere. All the layers of the earth are called sphere because our earth is a sphere. Okay, so we've got our inner core and our outer core. So this represents the core of our earth. So now we're going to do the mantle. So I'm going to use yellow for my mantle. I've got quite a bit more mantle than I do of the cores or of the crust, and that's because the mantle is the thickest layer of earth. And the mantle, kind of like the core, is in two parts. We've got the lower mantle that's solid rock, and then we've got the upper mantle, which is sort of solid, sort of liquid. Okay, and so we call the upper mantle the Asthenosphere. So I'm just kind of moving that around, and I'm just moving my Play-Doh around so that I can try to make it as thick over here as I have it over here in the part that I rolled out flat. And so the lower mantle is solid, and it's got still got some iron and nickel. It's got some magnesium, some silicon. If you remember back in the fall, we did a little pie chart of what all the composition of the earth, the soil is, the crust is. And so we had a lot of that silicon and oxygen, and so we call those silicates. And so that's a lot of our soil is made out of silicates. So there is my mantle all wrapped around my cores. And so now I'm going to take my green, and I've probably got, this is my crust, and I've probably got way too much here. So what I want to do is I want to mash this crust out until it is literally like see-through thin, okay? Because our crust is our thinnest layer. It goes on top of the mantle. It specifically goes on top of the asthenosphere, that what we call the weak layer, the weak rock layer that's flowing like a liquid. And even though our crust is going to be all one solid piece, our crust is actually broke up into plates, and those plates are floating on top of our asthenosphere. So when I hold this up to light, I'm starting to see little very, very, very thin spaces where I can really just kind of see light through there. So I'm going to stretch it out even to where it's just very, very thin on there, and I'm going to take off as much as I possibly can because my crust is supposed to be thin, 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 super thin. Maybe even with little holes in it, because really we do have some holes, and that's where our magma comes up. I can tear some of that off. I've got a little too much. I knew I was going to have to do that. I have to have some mountain building here. All right, let's get that. Take that together. Put that on there. Once I get this wrapped around, I'm gonna we're gonna do a cross section of the earth. So last week we read about what a cross section is. So if we could cut the earth in half and look inside of it, and of course, you know, it's a little bit of speculation. We haven't really gone inside of the earth and looked because it's very, very hot, and if we tried to go in there, we'd burn up. So if you ever watch Journey to the Center of the Earth, it's going to get really, really hot, so we can't really go there. Pull that off, and pull this off. Put that together. Oops. All right. So, probably got my crust a little thicker than I really like to make it in class. But I'm trying to hurry because y'all know these videos don't allow you to download a whole lot. All right. Tape over that. There we go. Okay. So now I've got my earth with my cores, my mantle, my crust. I'm just going to kind of roll that out, try and smooth out some of those seams. Okay, so this is a little bit bigger than the one that we're going to build in class. I didn't have the same measuring tools that I usually use at school. So what I'm going to do now, so if you're doing this with a partner, one will hold it in their hand and the other one's going to take some fishing line. I'm going to take some fishing line, I'm going to wrap it right around the middle. Let's call that our equator. And I'm going to take it just like that, and I'm just going to cross it and then pull my fishing line. And when I open it up, there's my inner core, my outer core, my mantle, and my crust. All right, so we're going to mark that asthenosphere, and the lithosphere. So the lithosphere really kind of makes up the crust and the very top part of the mantle. And since it's in plates, what I'm going to do is I'm going to go here with my toothpick and I'm going to draw some straight lines, kind of like that's my plate area. So that's representing my tectonic plates that are sitting on top of this asthenosphere. And we have convection currents. We've learned about those. And that asthenosphere and those plates float on top of it. That's what causes our land features and our geologic events that we're going to be talking about and that you've certainly witnessed and seen all of your life. We have mountain building, and we have earthquakes, and we have rift valleys, ocean ridges. Okay, so the straight lines represent my lithospheric plates that are sitting right up at the top near the crust, holding up the crust. And then I'm just going to use little dots going around to represent that upper mantle that is that asthenosphere that flows like a liquid. It's rock that flows like a liquid because it's so hot and so melty. And that's what causes those plates to move, because it's ooey gooey and it's moving all the time. So there we go. So you'll be making this whenever we come back, and I'm going to put some other things for you to read about and then answer some questions on your Google Classroom, and you will have a STEM Scopes assignment in there. So I look forward to seeing y'all in a few days, and I will talk to you later. Have a great day.